Figures are graphic representations of material that you want to present. So in a figure, what you're doing is you're doing something graphically so that people can look at it and see what you've got. When we have a figure, we label it either with the word figure or with the abbreviation FIG. This is going to vary depending on where you are doing it and who is your publisher. Normally, the label is either on the bottom or the side of the figure, and the label should be complete so that the reader can understand what is presented, so that they don't have to go back to look at the regular text to be able to figure out what is exactly going on here. So it should have enough information to be able to do that. Let's remember, a picture is worth 1,000 words. Sometimes it's much easier to put up a figure than it is to try and explain something, especially if you've got something that's fairly visible. Figure type 1. This is a line drawing. And what you can see is we've got some data points, and the data points are marked. And you can see that there are some lines that are indicating that are giving you a visual representation of what's going on. Legend says, Figure 1, relation between percent tissue calcium, which are the little balls, and anthracnose, which is the X, of soybean seedlings grown in modified Hoagland solution. So we know that soybean seedlings were grown in modified Hoagland solution, and the modification was that the calcium level was varied. We can see how much calcium was picked up by the plant, and we can also see what the disease level was after they were inoculated. And you can see a very strong positive correlation as the amount of calcium went up, the amount of calcium in the tissue went up, and there's a very strong correlation as the amount of calcium went up, the amount of disease went down. We've got a line drawing, and we can interpret material straight out of it just by looking at it. This is a chart, figure 3X. The interrelationship of radiative forcing components that affect the amount of solar warming of the atmosphere of the Earth. And what we can see here is a radiative forcing component, and that's in watts per meter squared, of various materials, which include greenhouse gases and ozone and water vapor and black carbon on snow and other materials in there. And then at the end, it shows you the net anthropogenic component, which shows you how bad man-made materials are on this. It gives us a graphic representation of what is going on, and again, it is a figure. A photograph can be a figure. Figure 1B, a hot air balloon drifts over the trees. Note the flame in the black area that comes from the heat source that causes the balloon to ascend. And you can look in the center of it and you will see there's this great big flame that's heating up air, and that heated up air is now going to move this material upwards. So we've got a photograph. I don't know how you would be able to explain this so that somebody would actually be able to visualize what you're looking at compared to having the photograph. So when you've got something like this, it becomes very important to have figures that are as good as possible. Should you be in the figure? Only if your being in the figure helps the person to understand what's going on. I've seen figures where people are holding up something just to be in the picture, and that's not where it wants to be. I've also seen one where somebody is using a machine, and that, is much more tolerable in here. So we've got a photograph. So when we look at figures, we've got a lot of different types and forms that we can use. Which one is the best one? That's kind of a value judgment you're going to have to make.